Okay, so this is going to be our day 9 video, one of two for Geometry Unit 3. And in it, we are going to briefly define some special segments of circles, right? So, first one we want to talk about is chords. Okay, chords, to put it simply, are segments that connect 2 points on a circle. Okay, so for example, if I've got point A here and point B here. These are both points on the circle, right? And if we connect them with a segment, let me try to draw it not so crappy. If we connect them with a segment, well, we would say segment AB is a chord on this circle. Okay? So an inscribed angle. So that brings us here to EQ2. So say I put a third point on this circle, called it C, and I went ahead and connected it to point A, right? Now, let's say this was the center of the circle. Whoa. Okay, so where am I going with this? So this angle here, we can say that this is angle ABC, and actually it's supposed to be the middle one. We would have to say BAC or CAB. We'll say BAC. Okay, so angle BAC, which we're just going to call theta. Okay, we're just going to call this angle in here theta. Um, this angle here is half of this central angle here. Okay, so if I call this something else, let's do point D is right there. So BDC. So angle BDC is equal to 2 times theta. Okay, so this right here, this 2 times theta, well, that's a central angle. Okay, so that's a central angle. And this right here is an inscribed angle. So let me try to color code better here. So in green, that right there is an inscribed angle. Okay, so an inscribed angle is basically formed by two chords. Angle formed by two chords, right? And what's its relationship to arc measures and central angles? Well, real fast, let's go into central angles. So arc measures and central angles are not formed by chords, they're formed by radii. Okay, so they're formed by radii, and we see this relationship here, right? So the way you can word this is inscribed angles are half um, are half central angles or arc measures, right? Those are synonymous. Or you could also say um, central angles slash arc measures are twice um, inscribed angles. Okay, so that's basically all that we're saying here, right? And one last thing, we would call this, figure out what color I want to use, we would call this arc right here, this arc right here, so arc BC, right? We would call that arc, um, let's just say it's lambda, we would call that an intercepted arc. Okay, and I think I'm using the wrong symbols here for the angles. Angle BAC, I should be using that stupid little, like this. Almost looks like a less than symbol. I personally don't like using those symbols anyway. You're not going to see me use them a whole lot because, like I said, they look like less than symbols, but whatever. In case you see that, so this is angle BAC, BDC. The vertex is always the middle letter. Okay? All right. So we've talked about chords, radii. We already know about diameters, not going to get into that. Okay, so now we're going to talk about secant lines or secant segments. Okay, so I'm going to use my mouse this time and not my. So a secant segment looks like this. Okay, and I don't know how well that's showing up. Okay, but a secant segment looks like this. And what do we notice about it? Well, we see that it passes through 2 points. Okay, so if I call this A and this point here B, right? And let's say that this other point out here is C, right? So segment CB, we'll just say CB. Segment CB is secant. Okay, it is a secant segment. Okay, so from here to here, it is a secant segment. Okay, and what's special about them? Cuts arc twice. It cuts the arc at point A and point B. Therefore, segment CB is secant. Okay, tangents. Okay, so tangents are a little bit trickier to draw, we'll say. All right, so let's say that's the center of the circle. This is some point A, right? And I'll just connect it here. Yeah, it took too long last time when I tried to just use the drawing tool. Let me just use my stylus and try to use a ruler. So anyway, so what I am drawing, trying to draw, it's kind of hard to do this on a tablet with a ruler. What I am drawing is called a tangent line. Okay, so this line, let's just call this L. This line here, L, is tangent to the circle. Okay, it cuts the circle at precisely 1 point. So tangent lines or tangent segments cut arcs at one single point. Okay, so secants cut twice, they cut at 2 points, right? Tangents cut at one single point. Okay, another example of a tangent, it wouldn't necessarily have to look quite like this, but another example of a tangent, let's say a tangent segment, let's say it passes through this point here, and you'll understand when we talk about the theorems why I always draw a radius before I do a tangent segment. But anyway, here we go. Still didn't quite go well. But let's say that this was point D, this here is point F, and this is E. Okay, so segment DF, so this is a segment now, is tangent to this circle with center C. We'll just call it circle C, who cares? It's tangent to it because it cuts it at precisely 1 point. Okay, same as this line L. Okay, so I think that does it for this video. Yeah, I think that does it for this video. In the next video, we'll talk about circle theorems. So if you have any questions over radii, diameters, chords, inscribed angles, secants, or tangents, or intercepted arcs, obviously feel free to let me know either via email or you know where to find me in person. Goodbye.